high-speed fuzzing can be used for any protocol. High-speed fuzzing, basically, when you use model-based tools, any protocol that can be run in parallel is automatically, of course, supported in high-speed mode as well. Only thing you can need to do with all of our default tools is just execute more of the tools in parallel, and then you'll create a high-speed version of it. In test setups, you have some challenges. For example, with many routing protocols, there is restrictions on the test targets that you only can send one test case per second or one test case per 5 seconds. If you can go through, around those restrictions in the system under test, then you should be able to test using load as well. Another example is that even in our small setups that we did for high performance, we noticed that quite often, extremely fast, the test generator was much more effective in actually generating test cases than the SUT was in processing them. So as a rule of thumb, you often need at least as much processing power for the test generation as you need in actually processing those test cases. So if you have, for example, a business critical service running behind load balanced cluster of servers, then most probably you need equally big cluster of test generators in order to test it to the limit as well. So model-based tools are not performance optimized like some of the very low-end hardware-based solutions are, but on the other hand, they are very flexible in the hardware setups. So if you have a cluster of Linux computers, then exactly the same hardware setup can be used for fuzzing as for other test scenarios as well. So you can reuse the test environment for fuzzing as well as for other types of testing as well.
Okay, thank you. You also talked about finding specific issues that you cannot find otherwise with high-speed fuzzing. Is there a chance that these issues are actually false positives if they cannot be found otherwise with fuzzers, or what types of issues are these?
So there's one type of false positive that immediately comes when you do parallel fuzzing, and that comes from, for example, in this setup, when we have two parallel processes, each one of them running parallel threads as well, and then any one of those test generators, if that causes a problem in the system under test, then of course every one of those parallel test generators will think that it was them who found that issue. So if you have 200 test generators running in parallel, and if you find an issue, it will be labeled in the test result 200 times. So reproduction of those tests becomes much more critical. So being able to select failed test cases, select test cases that caused performance degradation has to be done then individually after the test. So there are more initial false positives when doing parallel testing, but on the other hand, it's very easy to verify those as all the parallel tests can easily be combined into test projects, and you can then rerun those tests very easily and verify the actual individual inputs that cause problems. The other category of challenging problems is that quite often in fuzzing, a crash or an issue failure in the SUT, DUT is caused by combination of two different test cases or running an individual test case in a loop. And repeating those scenarios becomes much more challenging when you do parallel testing. And in those areas, it's often critical to use offline or some other monitoring tools like our network analyzer product to be able to collect the actual traffic during the test execution and then bookmark those and verify that you can actually go back to any single test scenario and reproduce those from the capture. So combination of parallel testing, network analysis, traffic capture, fuzzing can help you reproduce some of those challenging issues. But yes, if you just use dump parallel fuzzing, then reproduction becomes extremely challenging. So parallel fuzzing done with any other tool than model-based tools usually ends up in lots of issues that you cannot reproduce, and that doesn't really help anyone at all. So reproduction and documentation of the test scenarios is extremely critical, especially in parallel fuzzing.
Thank you. We also had a question relating to test setup configurations. So the person asking the question is looking for help to configure the tests. So like test sequences and messages, how they need to be defined. So I think this is an issue that support will gladly help you with. So I will forward this question to our support team and they will give you a more thorough answer. Unless you want to say something on the topic, Ari.
If we look at the test cases and the test message sequences and such, you can use our tool, of course, in the editing mode, and you can add and modify all the pre-generated sequences or create your own ones. If you want completely, if you want those done for you, then as Ami said, our support people are happy to help you with that.
Yes, indeed. So you should get a more thorough answer slightly later on. And also, one of our attendees is questioning the fact that you can do high-speed fuzzing for BGP. Can you really do that, or?
BGP testing, routing testing is extremely challenging in high speed because most of the configurations don't support that. But if your configuration supports that, then definitely model-based tools can be modified to run that as well. So I don't see any problem in generating lots of BGP requests. I think the biggest challenge is actually the DUT or SUT processing high speed fuzzing for some protocols. So like I said, you can generate load using fuzzers by just adding and adding more parallel test generators and executing those in parallel. If you have one test suite running at like 10 test cases per second or 100 test cases per second, then adding 100 test suites in parallel will increase the test execution 100-fold. Until you meet some bottleneck, which is often CPU, memory, or network resources.
Ari, could you tell which Codenomicon test suites support multi-thread execution?